Hello, welcome back to our course, Electronic System Design. So, our next topic is Reliability Basics. Okay, so up to now we had discussed about the product and their design, development, and how to design a product with the help of overall product design, and also how to protect and um, how to mark the protection for your system. Also, we had discussed. Now we will see the reliability. So how to calculate the reliability of any electronic device that you had manufactured in the any organization or any company. How we need to measure. So which type of formulas we use to calculate them. So that we will see. So here you need to know about the two parameters that are function and reliability. So these are very important factors that will impact on the system quality. So you know the terms, the quality and quantity. So quantity means number of items or number of products. Quality means you should say it is a brand. So what is the lifespan of that product? So that you have to say about the quality. So coming to here, the quality will be depends upon function and reliability. So functions we already discussed, right? So every electronic system should fulfill its required functions based on the given parameters. So here parameters are nothing but output, and another name you can say it is a response value. So within a specific boundaries. So it will cross the boundaries. For example, if you are giving input, then you are expected something output has to come. But the device functioning is different. What will be happen? The device is malfunctioning. So customer is unhappy because your products are not good. Even if we buy with more amount also, they are not at all satisfied. So for this, what we need to do as an engineer, we should specify some function parameters properly. Next, what is reliability? So reliability is a measure of the performance of these functions for a given period. So certain period of time, maybe the device may get damaged, right? Which means that is not reliable, that is not functioning uh, good. What we have to do? Again, we will go for the repair. So repair means the device lifespan will be get reduced. So same, the reliability of the system also get reduced. So those are the two functions, reliability and function. Okay. So here what is parameter boundaries? So parameter boundaries by the predefined operating modes and conditions of usage, and along with maintenance, storage, and transportations. All these are very predefined in the operating modes of your devices. High reliability means high reliability means failure rate is very less. High reliability is especially important for electronic system in industrial equipment where a device failure often results in production loss or rejects. So the associated costs in such cases may be higher than the initial outlay of the defective system. Which means what reliability is more means cost is also more because the device will not get failure within 1 year or within 2 years. It is having more number of years. Their life will be survived because they are done inside very well known, well supervised engineers worked on the devices. Here also one more factor you should be consider, that is price. Okay, so price increases and reliability is increases, and extra cost for the customer for maintenance and repair during the product life cycle. Why cost is increasing for the customer means, if repair will come means we need to do, we have to spend money, and maintenance for every 6 months we need to maintain our system. For example, you have a bike, for every 6 months or 3 months you need to give to the maintenance department. Why? Because if any failure come means, the maintenance cost is more than the repair cost. So that's why your devices, or in any devices, only bike, laptop or car or any machinery or any washing machines, microovens, anything at your home, the electronic appliances, you should be managed maintenance. So, so what will happen? The customer cost can be optimized by examining the relationship between the overall cost and reliability, that we will be see with the diagram. So here you can see this is the relationship between the cost, overall cost and system reliability. So see here, this is the overall cost and system reliability. Generally, on the x-axis, I am taking the system reliability. It is a control factor, and cost is the response, that is the output. Okay. So here I am drawing. So here I buy some device. So, so this is the purchase price of your device graph, and this is the minimum overall cost, and this is the overall cost of the customer. So here what it is saying is, so here you can see in this graph, reliability is very high. Okay, reliability is high here, which means which means cost is also very high. Okay, and slowly its cost is get decreasing, because minimum overall cost here you can consider. Then again the cost is get decreasing and touches here. This is the purchase price, and then it will gradually decreases, because so cost during the lifetime. So this is the cost during the lifetime of one product, because the device will getting repair, maintenance and breakdown, its cost. Okay, anyhow, if you buy a product, the cost is very minimum. Okay, purchase price is minimum, then slowly purchase price also increases later some time. By considering these two graphs, I am saying it is the overall cost for the customer. So this is the overall cost for the customer. Next we will see why there is no loss. There is a loss of reliability. Maintenance cost may exceed customer expectations. So this all will be done. We need to give guarantee and warranty cards for the cost. So salesperson didn't have any, so doesn't do anything, because he need to sell their products, and they need to get profit, right? So this is a business process. So once the device getting more repairs means, the business reputation may also suffer, and it may lose customer if the reliability of its products is lower than that of its competitors' products. So here I want to calculate the reliability of any devices. For example, I am taking a dice. It is having 6 faces. So E means event may occurs. 1 minus E means event doesn't occurs. So here the formula, that is the relative frequency equal to M by N. M represent number of occurrences of E for N tries. For example, a random event E4 on top occurs 15 times for 100 rolls of the die. So what is the formula? We need to here calculate 15 by 100. That is the number of occurrence of 15 for 100 tries. We are getting 0.5 in the above example. So for example, so die is fixed to only one value. That is the ideal die. You already know. The event occur. Suppose the event may occur or may not be occur. That is represented by 0 and 1, 0 and 100%. So here we need to calculate the relative frequency, determine the probability P of E. That is P of E should be calculated. Okay. So for example, I want a 4 occurrence only one time, that is 1 by 6. That is 16.67% of percentage of time. Maybe 4 will be get. For example, that is the relative frequency H of E. On the x-axis, I am taking the dice numbers, and the y-axis number. It may be occur and may not be occur. So here for 60 rolls, I am getting the graph like this. 1 may be occur, 2 may occur this many times, 3, 4, 5, 6. But if you are increasing the number of rolls, then the graph should be maybe reached to closely to each other, because the number of times the values are getting nearby. So here probability of rolling of a given number increases and the number of tests also increases. The total probability will be determined by using the formula. Product of these two events occurs 4 throws and twice. Okay, so this is the example. And 5 tries, 5 by 6, you can see for 2 tries or 3 tries. These are some examples. So here, what is the use of calculating the probability means? So the probability will help you to calculate the reliability. In the reliability terminology, you may get a 0 and 1. That is, the device may failure or may not be failure. May need get repair or may not get repair. Okay. So if you want to say this reliability with the help of one example, for example, I am taking a human, he may live 100 years. Okay. The reliability function probability of survival or unsurvival. Survival function ఉంటుంది. So R of t captures the probability that a system will survive in a specific period of time, that is R of t equal to N of t by N naught. So N of t represents the failure free units at a time t, and the initial stock is N naught, which represents the totality of working units at the starting time t naught. For example, here you can see here, for example, a human being maybe lives 100 years. Okay, so how to calculate the reliability function? Here on x-axis I am considering the years, and y-axis I am considering the reliability function, that is R of f. Okay, so second graph, on y-axis I am taking failure density function, and this is lambda f, also very important factor here, that is the failure rate. So here you can see at the age of 75 or 73, that is m equal to 73, that is the mean time to failure. Okay, so the graph, if you drawn between these two, the graph should be like this. So this is the survival period of a human. Maybe he may get start repair from this like hospitality, health problems like. So how to calculate the failure density function by using this reliability function means dr by dt. So rate of change of reliability is nothing but failure density function. So failure rate is nothing but reliability function and also failure density function. Okay. So if we divide failure density function with reliability function, you may get this answer. It is 1 by r of t into dr by dt. So this is example for human groups. Okay. If you take a number of human groups and number of aged people, you can calculate their reliability and failures. Okay. So here reliability parameters only 50% of the initial stock of human group may be allowed at 76 years. In other words, a given human being 50% of chance of living to 76 years old. Okay. So here the reliability function R of t can be calculated with the help of two very important parameters that are mean value. Here I am calculating M for mean value, M for the repair units called mean time between failures and mean time to failures for non-repairable units. So mean time between failures is for repairable units, mean time to failure is for non-repairable units. That M equal to integral of 0 to infinity R of t dt. So here we can calculate the mean lifetime with the help of um, that equation. And also, for example, mean time to failure 73 years. So above figure we had already seen. So 50% of the initial stock still alive. Okay. So that is the failure rate of probability element with the fail before time t and complementary quantity of reliability function f of t equal to 1 minus r of t. So with the help of this relationship, it is sufficient to know one of the two functions as a function of time. For example, one can observe the fraction of population of components that fail at a time t in order to estimate the value of the failure of distribution function at this time. Here what I am saying, to calculate the failure rate, we can go a failure density function, that is df of t by dt equal to minus of dr of t by dt. So here failure density function is the mathematical derivative of the failure probability and thus define how the failure distribution function changes with time. So here very important, that is failure rate lambda t that we had seen above the figure. So here we have three failures: early failures, random failures, and wear out failures. So early failure means starting stage of devices get damaged. Okay, random failures means may be damaged or may not be damaged. Wear out failure means there is no failure in the device. Okay, so this curve is look like a bathtub curve with a decreasing constant and increasing failures rate of a function. Okay, so how to calculate this failure rate? This failure rate thus defines how many units will fail on an average in a time unit. The critical parameter here defined in the failure time unit, that is the reciprocal of time, that is h minus 1 failure per hours. The failure rate cannot be measured for an individual unit and it can be estimated from the observations of the failure rate for a large number of similar units. So that is the one formula here given. Lambda of t equal to change NA by N of t into dt. So here delta NA represent number of failures in the given time in the interval of delta t and N of t represent number of all units. Okay. So here we will see three failures: early failure and random failures and wear out failures. Early failures is an infant mortality failure or early failure, life failure rates occurring during the early life of the product due to manufacturing defect in escape detection. Okay, so without going to manufacturing, the device will be delivered in the market. Okay, that you called as failure rates. Random failures are nothing but expected product lifetime. So during the product lifetime, the device get maybe fails. Okay. So for example, late failures occurring end of the life service through wear and tear, fatigue, aging, etc. Okay. Dresses if you wear many times means maybe decrease their lifetime. Okay, aging due to increase in the age of human being also get failure. So failure is common for all the devices. Okay. So this random failures are stable failures. Whereout failures are failures occurring end of the services life through wear and tear, fatigue, aging, or etc. So this is the way you can calculate the reliability parameters, and exponential distribution is also there. With the help of this, you can calculate these three: reliability function, failure density function, and failure rates. So this will be done by exponential distribution functions. Okay. So for Gaussian normal distribution using the formula also you will be get. So Weibull distribution says depends upon the beta value. So beta based on the beta value, the reliability failure density function failure rate will be defined. So for exponential distribution, that is n of t by n naught, that is e power minus lambda t. Okay. Here n of t represent failure free units at a time t, and n naught represent initial stock. So failure distribution function f of t equal to 1 minus c power minus lambda t. So this is the graph you can see with the help of service period and the reliability function, failure density function, and failure rate. All will be get in one graph. But here, mean time between failures will be depend. It will depend if you draw a line between uh, failure distribution function and reliability function, you may get here. So this is mean time between failures. So here the device may get failure at 33%. Okay. So here also they given some formulas for failure rate, f of t by r of t lambda, and mean time between failures and mean time to failures also considered. It is nothing but reciprocal of the failure rate. Okay. So for example, failure rate maybe depends upon the device lifespan. So that we will be discussed in the next class. So failure rate will be depends upon mean time between failures and mean time to failures depending on their um, supply and age, fatigue, all these things. So thank you. The next topic will be continuous.